welcome back to my channel. In this video, we are going to discuss about clinical and laboratory thermometer, conduction, convection and radiation, conductors and insulators, sea breeze and land breeze, absorption and reflection of heat. So now let's start. Let's start with the first topic, that is clinical and laboratory thermometers. And first of all, let's start with clinical thermometer. This thermometer is called clinical thermometer as by its name we can understand that it is used to measure the body temperature of humans. It has a measure of 35 degrees Celsius and 42 to 42 degrees Celsius. This is because the human temperature cannot go below 35 degrees Celsius or above 42 degrees Celsius. And if we look in the far left side, we can see a bulb-like structure. This is called a bulb and it contains mercury. It is a type of liquid that rises when exposed to temperature. And this thermometer has a small thin tube at the center. That is called a capillary tube. And the whole thing is made of glass. And next, there is something that is not given in this image over here. That is, there is a small bent-like structure near the bulb. This is called a kink, and it is not, as I said, it's not mentioned in this photo. This kink prevents the mercury level falling down on its own because we keep this thermometer under our tongue, and after 1 minute the mercury level has risen to our temperature. And if there is no kink, as soon as we take this out of our tongue, the mercury level will fall below 35 degrees Celsius and we cannot look our temperature. The kink stops the mercury level from falling down for some time, and after reading the temperature, we are advised to give it some jerks with our hand so that the mercury level goes down below 35 degrees Celsius. And there are many precautions to be used while using a clinical thermometer. The thermometer should be washed before and after use. We can use any liquid like antiseptic solution. Next, before we look the temperature, we must ensure that the mercury level is below 35 degrees Celsius or else we will get a wrong reading. Now, then we have to read the thermometer by holding it straight and do not hold it by tilting. And handle the thermometer with care because it is made of glass, as I mentioned. So if it hits any surface very hard, it may break and the mercury will spill in the floor. And mercury burns while touching the hand. And then do not hold the thermometer's bulb while reading the temperature. We can see these type of thermometers in hospitals, and also we can see sometimes it may be there in your own home. And there's many concerns of using these clinical thermometers because it contains mercury and it's a very toxic substance. So in case accidentally if it comes into our mouth, it's very toxic and may kill us. So there is now digital thermometers over here, and not only that, there is also some problems using these type of these clinical thermometers in overcrowded places because we have to detect temperature very fast, and this clinical thermometer needs 1 minute to measure the temperature. So this type of machine, it is pointed against our forehead or our hands and it measures the temperature very fast. And now let's go to the next part, that is laboratory thermometer. As I said, the clinical thermometer only can measure temperature from 35 degrees Celsius to 42 degrees Celsius. So what do we do if we want to measure things of hot or cold objects? If you try to measure the temperature of boiling milk with the clinical thermometer, you know that it is 100 degrees Celsius the time when the water starts to boil, and can only measure temperature till 42 degrees Celsius. And if we keep in the hot milk, the mercury level wants to keep on rising beyond the limits, and it actually bursts the end of the tube due to pressure, and the mercury spills everywhere, and if you are standing in front of it, you can get burned. So this type of thermometer called laboratory thermometer is used. This thermometer's advantage is that it can measure temperature from negative 10 degrees Celsius to 110 degrees Celsius, but it does not have any kink. So as that moment you take it from the boiling thing like milk, or if you keep it inside ice, we can measure the temperature of those things. And if we keep it inside milk and take it out, that instantly the mercury level falls way down and we cannot measure the temperature. So we have to keep this thermometer still in the hot object like the boiling milk and then look the temperature. And it has some similarities, like both have a capillary tube in the middle, both are made up of glass, and both have a bulb which contains mercury. Now let's go to second topic, that is conduction. This happens without the movement of particles. For example, you think we have an iron rod over here, and here there's some fire and it's getting heated, and after few minutes you touch over here, it becomes hot. How? This is how it happens. First of all, when the fire is placed over here, the particles over here gets heated. And as I said, there's no movement of particles, and it transfers the heat towards here to the next particles over here, and then that transfers the heat to the next particles, and no movement of particles takes place. And like that, from transfer to particle, this continues till here, till the tip. Here is the next one, that is convection. And for a great example, you can take boiling water, and you imagine that this is a tub of water, and there is flame right below over here, and there's many particles of water inside, and there's many particles like this, many of them inside. And here the particles at the bottom first get heat up over here, and the top ones are cold, and these heated up particles move to the top, to the both sides, because when the thing is heated, it generally goes up. And here there's many particles over here that is cold, and this thing rushes down over here, and that particles also get heated up and move back up. This process continues like this until all the water gets heated, and that is at 100 degrees Celsius. All the particles inside are heated up, and there's nothing to be heated, and that's how the water starts to boil. The next topic is radiation. This happens with or without a medium. And in lower classes, we have learned that sun gives us heat and light. But from now, we are going to learn that sun radiates heat and light. The sun gives out heat and light, and we can take example of heat because the chapter is about heat. And the sun's heat travels from here to the earth. But here, as in the conduction and convection, there is particles, and in conduction there is no movement, and convection there is movement of particles. But in space we can call it as a vacuum. That means there is no particles over here, and conduction and convection will not be possible without particles, and this radiation can be present with or without particles. So this sun radiates of heat and light, and that comes here and touches the earth. The sun is not this near to us, it's very far away from us, and this is about radiation. Let's go to the next topic, conductors and insulators. First of all, let's go to conductors. Conductors are the items that easily conduct or pass through heat or electricity to it. You may have heard that if you hold a iron rod that is connected to electricity, you may get a shock, and that's true because it allows electricity to pass through it very easily. There's many examples for conductors such as iron, copper, etc. Is insulators. These are items that do not allow heat to pass through them easily. For example, we can take plastic, scale, rubber, etc. And that's why these electricians use rubber things to keep it in the head of screwdrivers, pliers, etc. Just because they insulate the electricity and heat coming from electrical sockets. Now let's move to the next topic of this video, that is sea breeze and land breeze. First of all, sea breeze, and that happens during the day. And here is the sea and here is the land. and the sun's rays heat up the air in the place of this land more faster than the area of the sea. So as we have learned in the process of convection, heated thing molecules like to go up, and so this heated air right over here goes right up. As these things go up, there is nothing over here, and so the air placed in the sea is less warmer than on the land. So this cold air rushes to fill the gap over here left by the warm air rising up, and therefore we can feel the wind going this side. And the next one is land breeze. This happens during the night. This time the air in the part of the sea is a bit more warmer. We cannot say hotter because it's not like boiling hot. It's a bit more warmer than of the land. So the warm air usually likes to go up. The warm air from the sea goes up, and there is much of cold air over here, and this cold air rushes to fill the gap left by this hot air rising up, and this air over here also gets heated and goes up. Therefore we can feel the wind going from the land to the sea. This is called land breeze. This happens during the night, and it is the exact opposite of sea breeze. So now we are going to the final topic of this video, that is absorption and reflection of light. And over here we can see two not so similar cans. If you want to try this experiment, you can take two similar cans in your home. The one is they should be painted white and one should be painted black. And take this and fill same amounts of water and keep it in the sun. Then observe after some time. See which is more warmer than the other. You'll see that the black color is a bit more warmer. I cannot say hotter, but a bit more warmer than the white color. Why? Because white color reflects the heat coming from top. It reflects right here, and the dark color absorbs the heat. So this water in this container is a bit more warmer than the white color. So I'm planning to wind up my video. Please do not forget to like, subscribe, comment and share. So I'm winding up. Thank you and bye.